Hello, I'm Kip Schwanke, Executive Producer.
I'm Christine Quigley, Editor. Welcome to Videographix Today.
In this issue, we have
Video imaging using toaster paint.
products to increase and enhance your Amiga memory.
NewTek's Video Toaster, the ultimate guide.
And we'll be making a visit to Video Transfer Studios.
We have Brent Malnack demonstrating Morph Plus.
And the gallery. We hope you enjoy this issue.
Hi, I'm Mars Booth. I'm with EE Computer Systems. I'm a video toaster salesperson, have been for 2.5 years. When I'm not doing toaster sales, however, I work for Brent Malnack, who's an animator here in town. He also happens to be my husband. What we're doing here today is a little video imaging using toaster paint. And I'm going to get some revenge on a person named Les. Les is a co-worker of mine who tells a lot of dumb blonde jokes. So what we'll be doing here is using toaster paint to remove parts of his hair. We're going to age him quite a bit. We'll add a couple pounds to him. And we'll just see what happens as a result. I hope you enjoy it. Okay, what we have loaded in here is a frame store of my co-worker Les that was taken at a trade show. We've loaded it into toaster paint. You can see that there's a lot of people in the background. We're not going to worry too much about that. What we're going to do first is start at the hairline, start removing the hair up at the top. And how we're going to do that is by patching pieces of the background in. So I'll take my rectangular and my fill tool and my scissors, and I'll just cut out a piece of the background like this. And we'll just patch it into the top. Now you'll notice there were some light changes in that brush, and there's going to be some lines of demarcation where the repetition occurs. That's okay, we'll patch that up later. The main thing we want to do is to have a solid background and start removing the hair here. Okay, once you've done that, render to see what it looks like. Yeah, that looks pretty good. Now what we'll do is patch in skin to go up and meet that hairline. I haven't removed all of the hairline yet because I want to preserve what this curve looks like. I want to be able to go back and put the skin up there later. So you take what looks like a good piece of skin. It's going to be pretty light up there. And you do the same thing as you did before. Now it looks like this skin doesn't match yet, but we can blend that in later. But actually, if there was no hair there, there'd be quite a bit of sheen there. You could see it on the forehead. So this piece of skin will do nicely. And render that change. Looks pretty good. Now what I'll do is use my freehand tool and fill in here. I want a nice, even skin tone throughout the whole picture. You can see this matches pretty well already. Now what I'll do is with this same piece of skin I have cut out here, we'll go into our transparency menu and back that off quite a bit. This is what we're going to use to patch our lines of demarcation. Probably your first instinct was to use like the bluer tool, but it ends up just mushing the pixels together and you don't get a very natural looking result. So I'll use transparency. Looks like we need to back that off just a little bit more. I'll render some more changes. Looks good. Okay, now we're going to use that same technique. We're going to use our freehand filled tool, use our scissors. We're going to cut out a piece of what looks to be a pretty smooth looking background, and we're going to fix those lines that delineate light and dark through here in the background, just the same way as we did the forehead. Don't worry about overlap. We'll take out other pieces and fill those in later. That's all video imaging is. It's really taking what's part of the picture, the original elements of the picture, and just covering over the elements that you want to get rid of. And we'll turn on some transparency here and smooth our background out as well. Let's render the change. Now that I've got a pretty good definition as to our hairline, where it meets the background, we'll go back in here and match this part of the forehead with this one. How we'll do that, we'll just, let's do a freehand tool. Pick up that piece and do a flip horizontal. And I have transparency turned on. Don't turn transparency on. And there's our other half of the forehead. And we'll take out a piece here, patch that here. Now let's take a clear patch of the shiny portion of the head. Drag your brush over into a dark portion of the screens, and I still have a piece of that furrow here. There's a good clean patch. Turn on transparency again, back it off almost all the way. Now we'll put some shine on the forehead. Let's render that change. Nice, looking better all the time. I'm starting to go over the hard edges that I cut out earlier. These will be smoothed out by very tiny brushes that I'll cut out later. Now what I'll do is make the lines in his forehead, the furrows in his forehead deeper. What we'll do is use our pick tool in this menu here. Go in and find the darkest pixel in the furrow. Then we'll go over here, check our transparency. That looks pretty good. We'll use the freehand tool to just go in here. Oops, undo. That's a common mistake I make. You don't want the fill tool on. Let's draw that again. And you really want to check your work closely in this. That looks good. Check for different levels of transparency, what works. You might want to go in and start with an even more transparent brush, do an undo, and redo it until you get the ideal amount. We'll go over here and do this one now. Now we're going to go in and start painting the areas of his hair, his mustache, what's left of his hair and mustache gray. So what I did is I went in and I chose what looked like a good mid-level gray. Let's try 128, 128, 128. And you're at about 75% transparency. Again, we don't want to color over the hair. This part is the only part that we're not directly using from the picture. So what we want to do is not harm the architecture of the hair beneath. We want to still be able to see that, but just to lay some transparent color over that. So we'll do that. And it's going to take quite a while before you really see the results of these hairs. Vary the colors. It's going to give the picture some depth.
Mars continued to add gray to the rest of the hair, the eyebrows, and the mustache, cleaned up the hairline, and then went on to adding some weight around the neckline.
Turned on my freehand draw tool, filled tool, cut tool, and it's going to take maybe a couple tries to get it right, but you cut out his actual chin. So you take this, just this piece right here, and you keep adding it, kind of moving it down. See how easy it is to gain weight? I could have even gone further out this way, made his cheeks a little fuller. And there we have it, less old, fat, and bald.
Hi, and welcome back to Products and Equipment. My name is Lance Hutchinson. Today we're going to look at 3 memory expansion products for the Amiga series computers. The first product we're going to look at today is the DKB MegaChip 2000. The second is the 68040 card from Progressive Peripherals, the Zeus 68040. And the third is GigaMem from Innovatronics. The MegaChip 2000 allows you to expand the Amiga 2000 and 500 to 2 megs of chip memory. Chip memory is like the memory that's on VGA cards on DOS-type systems. The chip memory on the Amiga is unique in that it can also be used by programs. This is extremely useful for software like Scala, AdPro, or the Video Toaster Toaster Paint programs. The second product we're going to look at today is Progressive's Zeus 68040 accelerator. Designed for the Amiga 2000, it's available in several different configurations. It's available at 28 megahertz and 33 megahertz. The 68040 in general is going to give you 2 to 4 times speed of improvement over 50 megahertz 030, depending on the type of software you're running it with. the 68040 is most useful for applications like the Video Toaster's Lightwave, Imagine from Impulse, or other 3D rendering type software. The Zeus also has several built-in unique abilities, such as memory expansion and a built-in hard drive controller. The Zeus's memory is expandable between 4 and 64 megabytes of RAM.
So you're going to show us how to put this in our system?
Yep, we'll take you in the other room and show you how the Mega Chip and the 68040 work together.
Super, let's go.
All right. Let's take a look at the Mega Chip 2000 and how you put it into the Amiga 2000. As you can see, it's a very small assembly. It comes in a static sensitive bag. The Mega Chip itself has very few components on it. Consists of the new Agnes chip, the 8372B from Commodore. It has 2 memory chips, one on the top, one on the bottom, each being half a mega RAM for your 1 meg expansion, and then the new socket that goes into where we take the old Agnes chip out. And then it has a connector that attaches to the Gary chip for timing adjustments. Let's take the Amiga apart here and show you where this all goes together. There are 5 screws you have to remove on the outside of the case, 2 on each side of the machine and 1 in the very rear of the machine. The second step is to remove the 7 screws that hold this power supply assembly in, so that we need to remove this so that we can get at the Mega Chip, which is basically right under the power supply. The 7 screws, there's 3 in the front and then 4 in the back on the power supply. Once you've removed those, you can grab right here in the middle and gently pull the whole power supply assembly right out of your system. Now when you get it out, you'll notice there's 2 connectors still holding it. One for the floppy drive, which you can gently pry up, and the other for the power supply, which also just pops off. Now that we can see all the chips, the 2 chips we need to pay attention for the Mega Chip are the Agnes chip and the Gary chip. We need to remove the Agnes chip with a special tool that's available from your dealer. This is the part of the Mega Chip installation that is the most difficult and most dangerous, and if you have any qualms about removing this chip, please let your dealer do this. With this tool, you can insert each end into this slotted socket, and by putting pressure down on the tool and squeezing together, you can pop the chip right out of the socket. Then we can take the Mega Chip. You need to pay attention to the orientation of the chip. If you look on the top, there's text on the top of the chip, and this text should be oriented the same as the text was on the other chip. If in doubt, there are illustrations in the Mega Chip installation manual that help you reorient the chip the correct way. You need to carefully orient this and position it, and then the best way is probably with 2 thumbs or 1 thumb, just pop the chip into the socket. The only other connection is the connection to the Gary chip, which goes to pin 36. If you look at the Gary chip, this side of the chip in the back is pin 48, and normally I just count backwards from that. So 48, 47, 46, 45, 44, 43, 42, 41, 40, 39, 38, 37, 36. And then you have to clip this on to pin 36. Depending on what version your motherboard is, you may have to remove jumper J500, which is right here. Version motherboard 6.0 and above, this may be jumpered. If it is, just remove it. Please look in the Mega Chip installation manual for any other special modifications or jumpers dependent on the motherboard revision you have. Once that's installed, you carefully put the power supply back in. When you put the power supply back in, you may want to be careful and you may want to remove the toaster card if you have a toaster card, so that when you put the power supply back in, it doesn't catch these clips, because if it does, it'll pull this out, and then you've got to take it out again and put the clips back on. Now let's take a look at the basics of installing the progressive Zeus 040 card. If you have any questions or concerns about anything we do here, please refer to the manual. The Zeus card itself is made up of several system components, which we're going to show you on the card here. First, on the Zeus board, we have the memory banks. You'll notice that there are 16 slots for RAM. They're divided into 4 banks of 4 slots. So bank 0 is 1, 2, 3, 4, bank 2, 1, 2, 3, 4, etc. The Zeus board is the only board that allows you to mix both 1 meg sims and 4 meg sim modules. You must completely populate each bank with the same type of memory, but you could have banks 1 and 2 with 1 meg sims and then put 16 meg sims in banks 3 and 4. Or actually any combination of banks, as long as the 1 meg sims are in the first bank. The next thing you have to know about this is the memory configuration settings are right up here, and you can reference the manual. Depending on which banks have what type of memory, different jumpers need to be set. The 68040 chip itself, you can see, is right underneath this fan. The fan is necessary because the chip runs relatively hot. The next part on here is the SCSI control chip and the internal resistor packs. If you're using both internal and external drives, these packs need to be removed. On the back side of the card, we have the internal SCSI port, the power connection for an internal drive, and the mounting holes for an internal drive if you want to mount it on the card. And then the external SCSI port is on the back. Once you've configured the RAM by setting these jumpers according to the RAM type you have and the amount of RAM you have, the installation is pretty simple from there. You may want to note, if you have the support bar in your case here, you may want to loosen the screw on the back. That will remove the tension on the front panel here so that you can easily insert this card, as it is a full-length card. Also note that if you don't want to remove the power supply assembly, the manual does detail installation of the Zeus card with the power supply assembly in. Once you've got everything loosened up here, put the SCSI controller port in the back first, bend the front panel forward, and just slide it on down. And gently seat the card, and there are 2 screws on the back to secure the card in place. Be sure also to re-secure your tension bar. Other than that, that's all for installing the hardware. Just please refer to the manual for installing the software on your system. Now let's take a look at a totally different type of memory expansion for your Amigas. A product called GigaMem from Innovatronics. GigaMem uses what's called virtual memory. It uses areas on your hard drive, empty space on your hard drive, as either a file or a partition, and transforms that into what looks to be memory to the computer. Virtual memory is a system that's come over from Unix. Very popular. Most Unix systems use virtual memory. GigaMem works with any system that has a 68020 or 68030 processor that also has the memory management unit. If you don't have the memory management unit, GigaMem will not be of much use to you because it won't work. GigaMem will allow you, if you have up to a gigabyte of free hard drive space, to expand your Amiga to have up to 1 gig of RAM. So just about any application can be handled as far as memory requirements by using GigaMem. GigaMem virtual memory is much slower than actual memory because obviously your hard drive is slower than chips are. So one thing you have to remember is that your processing is going to be a lot slower on programs that use virtual memory versus real memory. Programs that are going to be used with GigaMem need to be added to GigaMem's compatibility list. There are a number of programs already in the list, including popular desktop publishing and word processing software packages. If there is a software package that you have that is not currently in the list, it's very simple to add it to the list. All you really do is drag the icon into the list window. Then each program can be specified whether it is to use virtual memory, real memory, or whatever is available. There are many other options available with GigaMem to improve system performance. GigaMem is also compatible with both Workbench 2.0, 1.2, and 1.3. They do prefer 2.0 or above. I've tested GigaMem with both the Art Department Professional and most of the toaster software, including Lightwave and Toaster Paint. It multitasks very well, and I did not have any problems with it at all. GigaMem is a very inexpensive alternative to adding memory to your system without stepping up to a more expensive accelerator card. That's about all for this segment of Products and Equipment. We'll see you next time.
CP Productions has a 2-tape tutorial set for toaster users. Called NewTek's Video Toaster The Ultimate Guide, Volumes 1 and 2, these tapes cover a wide variety of information for all ability levels. Volume 1 comes with a disc of toaster fonts and a CG keyboard overlay made of paper that you cut out and laminate yourself. Volume 2 comes with a disc of 3D files and a toaster paint keyboard overlay, which also requires it be cut out and laminated by you. Volume 1 covers quite clearly and concisely such topics as system configuration, switcher DVE, chroma effects, frame capture, and hints and tips. Volume 2 covers in more detail toaster paint, Lightwave, BCD controller, and the 2.0 upgrade. Here's a clip from tape 1.
Next, let's examine the preferences slice. The top row of buttons is for the selection of the background color. There are a variety of colors available, including on the end the selection of video noise. The second row of buttons is for border color, for those effects that use a border. We only need to select input termination for those inputs that contain more than one source, for example, a camera loop through a video monitor. If you terminate an input incorrectly, the result will be an overly bright output on the program monitor. The GPI trigger for specialized edit controllers. The project window allows us to select a storage or retrieval device for project information. We may save Chroma FX, Switcher FX, or CG books. It will also allow us to save a combination of all three for a particular project. The Frame Store window allows us to save and retrieve frame stores to any device present in our system. It also indicates the amount of space available on that device. Because of the size of the frame store, only one will fit on a floppy. A hard drive is recommended. The Freeze window is for motion removal, the interface to set the number of monitors used. The Exit button allows us to leave the toaster and turn on the overlay to run other programs. The OK button acknowledges any changes made and returns us to the switcher screen.
If the keyboard overlays that come with CP Productions tapes are of interest to you, you may want to give some consideration to Video Toaster User Magazine's keyboard template. This sturdy template has a plastic comb binder to withstand frequent use. The sheets provide handy references for switcher, paint, CG, modeler, and layout.
Video transfer started a number of years ago, chiefly as a film to video transfer business. And as low-end video editing has improved and the technology has increased, more and more that technology was bought and instigated into this business, where this studio here chiefly works as a low-end editing studio for post-production. We use the Panasonic MX-12 mixer for Super VHS editing, and more recently we've acquired the Video Toaster for either half-inch VHS, Super VHS, and 3/4-inch editing. And we set up a room chiefly for the toaster because of its applications towards those. Here we have our film transferring station. This is a typical film transferring station. Back there we have the film cleaning stations. And as I said, we use this much less and less as that business kind of going out. This is our typical half-inch editing booth. It just straight cuts only with a fader box and then a sound mixer in it. We set up this room about 3 months ago, incorporating the different types of videotape machines, and since that time it's been very popular. It's been our most popular room, chiefly because it interacts with the toaster. And I'm in here a couple times a day at least doing one thing or another, and often we'll have a customer in here, not every day, but I would say the majority of the days. What we've done is incorporated all the types of videotape editing we have here around the toaster, so anybody can access whatever type of videotape they have that we allow right directly to the toaster. And so we have a 3/4 inch VHS and Super VHS. We also have a camera mount here, which allows us to do photos or flat art directly to the toaster, and that's very helpful to have it right there, because often there'll be just a short, quick photograph somebody might want on a tape with an effect, and we can do that easily that way. Also, the countless times that we get flat art that we have to do some kind of manipulation of it in the paint program of the toaster. The help people need with the toaster depends a lot upon their prior experience with personal computers and their kind of ability to perceive the logic that the toaster uses in the different program applications. Generally, I can teach somebody to use the character generator and the switcher within an hour. Our customers range in quite a variety. We do get wedding videographers that come in, and generally they don't do the whole wedding on the toaster. They just save special moments. This is a presentation I did for a group that wanted this animation, and they wanted some kind of object in it that had some complexity, and I couldn't do that with the D-Paint. I could do goofball little animation with it, but I couldn't get a really three-dimensional object. So I incorporated the two. We don't have single frame recording here, so I couldn't do any 3D animation with the toaster. So by incorporating the two, I created this temple in the back and superimposed the D-Paint stuff over it, and we got a whole package that looked a lot more complex than just D-Paint looked. This is another one where they wanted a decent graphic, but again, we didn't have the animation, so we took their flat art of their logo guy here, and we superimposed that over a three-dimensional rendering of the planet they have in the toaster, and then by luma keying out the black that's behind the donut guy there, we were able to do an effect into the frame, so it looks like decent enough type of animation. If you'd like to contact us at Video Transfer Studios, you can contact Toast and Coffee Magazine, and they'll help you out to get in touch with us.
We're going to take a look at Morph Plus from ASDG, and we are into the actual morphing part of the program with this interface screen here. And we're going to do a still morph, which is essentially a morph between two images, a source image and a destination image. It is possible to do a morph on a series of images, such as doing it on maybe a live video segment or an animation. It's a little more complicated to set that up, but it's actually implemented quite well. We're going to go to find a couple of images here. I've just selected two images from the hard drive to load in to set up a morph, and it's going to give me a black and white display of those images on the monitor in just a moment. And what we have here is a little slider bar. They refer to this as the onion skin. Allows you to set different levels of transparency between the source image and the destination image, so you're able to determine what you're doing when you're setting up the vectors. So I want to set up a nice mix point, and you begin by setting up the first vector, and the vector consists of a source point and a destination point. And what is done in this program is you specify which points of the image are going to move to other points on the destination image. So what I'm going to do now is kind of find out in general where my corner of the eye matches up with hers. Let's get one more contrast here. And I'm going to move the destination. This is a very short move to about right there. Now, I continue to place a series of these vectors and instruct the program to connect them together. And finally, I lock the last vector to the first vector. And now I go through and specify where all the destination points are to match up with that. And for the most part, they won't have to be moved too far because the camera was positioned properly when we grabbed the two images. So I go through and highlight any individual part of the destination vector and move it to where it needs to be and let go. And you continue to do this one at a time until all of the vectors have been properly placed. I'm going to have to zoom in a little further here to be able to see what I'm doing. Okay. And much like a paint program, it is possible to scroll around as you're working on the image, which is handy as well. Okay, once all the vectors have been placed for an individual object, it's real handy to group them so that different parts of the images can be morphed individually at different speeds and at different transparency rates. So what I will do is select all the visible vectors that we just created. I'm going to add them to a group called left eye. And once they've been added to a group, if we wanted to at this point, let me zoom out, get the full images again, it would be possible to set up the speed for that particular group of vectors. And that's done by setting up a transparency and a speed curve. And this is a spline-based system where you can go in and add points to the process. And over the course, what this represents is over the course of the animation, the morphing would happen at different speeds based on the points you set here. And looking at this kind of curved S-shape spline we have right now, the morph would start off fairly fast, it would slow down for a little bit, and then it would continue quickly again as the vectors or as the points are moving across the screen. The same thing may be done with transparency curve, and the way the transparency curve works is to determine at what rate parts of the image dissolve in and out in those coordinates. So that may be adjusted as well by selecting it and adding a few points on it. And it's handy to make morph animations more convincing to set up different speeds for things so that it appears more organic. And if all the morphing happens at the same time, it's kind of a cold effect, and it's not quite as convincing. It might appear is that eventually it gets rather complex to place vectors with all of them on the screen. So it is possible to hide a certain group of them, and we'll just say to hide the selected group, and all that's left is an outline of where those vectors are set up. To continue with this morphing process, it's important to go through and follow the same procedure we did for the left eye for the rest of the portions of the two images. And quickly I'm going to try and set up the mouth areas on both images. Okay. Start a new vector, and you may notice that the size of the vector is determined by its size the last time a vector was placed. So to make the procedure a little easier, if I can, maybe I'll need to zoom in here, it's possible to set up how the vector will be placed. For instance, I've set this up to go up and to the left. Next time I place a vector, it's going to share that form. If I was getting into a part of the image where that wasn't working quite well, I could go through on the last vector I created and set it to maybe head towards the top of the screen. Now as I place vectors, they follow that format. So when I was going around the eyes earlier, I wasn't really paying real good attention as to how to get these placed. And a prime example is I'm at the edge of the mouth and I need to continue down now, so I'm going to start stretching the vectors off in a downward direction. And again, connect the last two vectors. Now I'll go ahead and go through and align those destination points to her lips. And because they're smaller, they're actually going to move inward instead of outward as I had set them up. And sometimes it's a good idea to keep a little bit of the previous image in the background. So I just changed the dissolve slider bar there. We're going to go ahead and get a few more of these placed. Okay, I'm going to add those to a group again called lips. And I'm going to go all the way around the outside of my image. Again, I'm switching the direction of the vector to go down the right side so we don't get confused. And close off the last vector with the first. And we have one continuous object. I'm going to quickly go in and move those vectors to the corresponding positions. And as she is a little thinner than I in the shoulders, we're moving the vectors inward. Now that all the vectors have been placed, we can kind of examine, and it's actually fairly easy to identify what might happen during this morph by examining the vectors and their positions. And we're going to go ahead and add that last group of them as outline. Okay, now we were going to actually set up the morph process. What needs to be determined now is how quickly the morph will happen. Commonly on television, morphs last about 15 frames, and the longer they are, the more points you're going to want to put in them so that they appear a little more realistic. So we're going to go ahead and go through now and tell it how many frames are in the morph and at what resolution they'll be rendered, and a few other factors, and these would eventually be laid back to tape via the toaster.